Hello, I'm Ammaly Tom and I present on the topic electric vehicle charging potential from retail parking lot solar photovoltaic awning. And this paper is about the investigation into the um, energy of the developing EV charging station that power from the solar PV canopy that built on the parking lot of a large-scale retailer of a Walmart. And a technical analysis will be performed on the parking lot area that located in the highest EV market, the coupled with a charge station rate and the charge capacity of the top 10 EV. And this technical will used to determine the solar energy generation potential of the most than PV parking lot canopy that designed by using the standard silicon-based PV and the high-efficiency silicon-based PV. And secondly, to determine the number of EV charging stations that could support by PV cover parking lot using this canopy, and as well as the percentage of parking customer that could be served. And finally, it's used to determine the percentage of charging capable during a range of shopping time, as well as the distance the EV could travel on that charge, and to determine the benefit to the customer. And move on to the method and the calculation. So first is the location. This case study is located in US, California, San Jose City. And these three Walmart is used in our case study, which is the two is supercenter and one is the neighborhood market, and its location is providing in the table, like you can see. And now move on to the software that used for the area and energy analysis is a PV Watt version 6.1.3 software. This software is used to determine the area of parking lot, the number of vehicles that can be parked in the parking lot, also the to estimate the solar electricity output from the installation of PV canopy. And in the table below here, table 2, it provides the detail the specification of the three case study from that we determined from the PV Watt software that has DC system size, the model type, the fixed array type, the array azimuth, the system losses, and the inverter efficiency, also the DC and AC size ratio. And move on to the structure. There are 5 main categories of solar PV parking canopy based structure, which are T, truss, long span, inverted, and garage. And in this study, we use the long span. Here you can see in the picture. And move on to the next slide is about the top 10 electric vehicle that we choose to study in this case study, which are the Tesla model, and the Chevrolet, the Nissan, the Hyundai, the Ford Focus Electric, and the Volkswagen, also Kia. It provides the range on the full battery capacity, the battery capacity, and also the battery acceptance rate of each model, like we can see here. And for the EV charging station, so this equation S equal to ED over R times HD is used to determine the number of charging stations, where the S is the number of charging stations, ED is the PV generated electricity per day, and R is the electricity transfer per hour by the charge station, and the HD is the estimated number of hours that the parking lot space is used per day, that we estimate to be 12 hours. And also, this equation is used to determine the number of miles that the EV owner could expect to travel based on the charge while shopping, where the R mark is the maximum charge rate, the capital R is the EV range in miles, and the C is the battery capacity. And to determine the percentage of EV battery charge, we use this equation, which is P equal to R mark times T over C times 100%. And we see that on the average, a customer spend 1 hour shopping for grocery per week, and thus the sensitivity is running for 5 hour, 1 hour, and 1.5 hour. And move on to the result and discussion. So we discuss on the 3 points, which the first is the potential PV canopy area for case study retestor here. The first figure is the figure of the Walmart one that we get from the satellite. And this Walmart one area is around 31,000 meters square, with the DC potential PV is about 4,700 kilowatt. And this is the Walmart 2 with the area, and the DC potential PV is around 1,500 kilowatt. And this figure 4 is the Walmart 3 with its area and the DC potential PV. And move on to the potential PV that generated electricity for case study PV canopy. So this graph is showing the PV electricity that produced from the parking lot in the case study retestor. And the blue curve is from the Walmart 1, which is produce the electricity higher than the other two, because the area of itself is also very big compared to the other two. And also this figure 6 is showing the amount of electric vehicle that charge with the PV electricity from the parking lot canopy. As we can see that the average number of cars that Walmart 1, 2, and 3 could serve with the solar electricity per day was 2,040, 640, and 493 for 1 hour shopping trip respectively. And we can see for 30-minute shopping trip, this value is increased. Also move on to the benefit and incentive of charging of the representative EV, the top 10 EV that we have talked about. So first, the charging station has 3 levels, but in this case study we choose the level 2 of the charging station, with there are 2 different versions of it, which are the Clipper Creek EHCS50, Clipper Creek EHCS80. And this table 4 below here, it shows the amount of charge that gain per hour, and also the time to full charge that using the 2 different versions of the charging station, which we can see that the HCS80 delivery rate is 15.4, and the HCS80 delivery rate is 15.4 kilowatt, and the HCF50 is delivery rate by 9.6 kilowatt. So HCS80 can be charged the vehicle faster than the HCF50. And we can see also for the Tesla model, we can see that the amount of charge that gain per hour is very high compared to the other type. So we can say that the Tesla model is performance good, very good. And move on to the other table. It show the number of miles per hour of charge, which the 1 hour of charge, which the 1 hour is the average time of people going shopping. So we can see that the number of miles per hour of each type of vehicle is here, and the shortest distance is 23, where based on the research, 90% of Americans live within 15 miles of Walmart. Thus, it is smaller than the shortest distance, so many shoppers could make a trip to Walmart and back without energy cost at all, because they can charge their electric vehicle at the parking lot while they're shopping. And also this figure 6, the table 6 is showing the percentage of EV battery charge depend on the shopping time, which are 30 minutes, 60 minutes, and 90 minutes. We can see that the amount of battery charge is increased as long as the amount of time for shopping increase too. So if the customer want to charge their battery to be to get the higher percentage, they might want to spend more time on shopping. So the longer time of the customer spend in the store means the more money the customer spend on shopping too. So it would benefit to the shop owner. And move on to the solar power EV charging spot that available. So we can see in the figure, this is the Walmart 1, this is the Walmart 2, and the figure 9 is the Walmart 3. We can see this is the available, this rectangular box here is the available spot that can use EV charging. We can see in the table 7 that the percentage of parking spot that can serve with a solar power PV parking lot canopy is between 8% to 21% in winter and between 22% to 27% in summer, because in summer the amount of solar flux is higher than in the winter. And move on to the next table is show the comparison between the standard PV model and the higher efficiency PV model. As we can see, the percentage increase output is about 2.11% for Walmart 1 and 3.05% for Walmart 2 and 2.02% for Walmart 3. So this also might could benefit to the store owner. Like the store owner also could get the profit from providing a free solar electricity charging station for the customer by based on this below mechanism, the four mechanism. And first, they increase the comfortable of their customer by providing shading. So it might be increase the store selection of customer. They would make the customer want to come to the store. And secondly, is provide a clear mode for green consumerism, which may also increase the store selection. And the thirdly is provide an incentive for the rapidly growing class of the owner of PHEV and EV to preferential shop at the store. And finally is increase the time shopping. Thus, the money spent by PHEV and EV owner at the store is maybe enable more charging. And now let I sum up the conclusion. So the average area available in the Walmart supercenters for solar canopy for case study 1 and 2 is around 20,000 meters square. That it results in about 3.1 megawatt of PV per supercenter, so as the solar potential of the parking lot. And in San Jose has a strong solar flux of about 5.12 kilowatt hour per meter square. Thus, on average, a Walmart superstore would be expected to serve about 87 of average of the case study 1 and 2. And in other words, it means that one US Walmart supercenter could provide potential of 3.1 megawatt PV and 100 EV charging station. So it means the entire United States Walmart could deploy 11.1 gigawatt of the solar canopy. Also, it would provide up to 346,000 EV stations with solar electric for customer. Also, it could cover 90% of American public with solar EV charging living within 15 miles of the Walmart. So this is all for the presentation, and thank you so much.